so I can post it later. Alright, so first question talks about, is this a one-to-one function? Okay, so this is a one-to-one function, and the reason being is because for every x I put in there, okay, I'm always going to get a specific y. Okay, now something that might not be a one-to-one function would possibly be something like x is equal to y squared plus 4. Okay, so if I give you that, you had to solve for y. First and foremost, it's not going to end up being a function, but you can square root both sides, you're going to get that plus or minus for your y value. Okay, and you can also think about your shapes too. Okay, this shape is going to be the square root function, that's going to be one-to-one. Okay, something x squared would be like a parabola, which, if you remember, okay, is to be a one-to-one function. Remember, it has to be a function, so it has to pass vertical line test, and then it also has to pass horizontal line test to make it a one-to-one. Okay, so let's go to number 2. Are these inverses? Okay, so remember, to find inverses, you have to find f of g of x has to equal x, and then g of f of x has to equal x. Okay, so your goal is to put g of x into f of x and see if you can get it down to x. Okay, so if I did that, this would go into here, okay, which would be, let me see here, let me get this here, give a little more space. Okay, so we would have 1 over 7x plus 1 over x plus 7. Okay, so you can do a couple different things. This one gets a little bit more work into it. You can get common denominator, which would be x, which would give me 7x plus 1 plus 7x all over x. Okay, so is that right? Did I read that right? 1 over this, so g of x. Make sure I'm reading my paper right. I think that's right. Doesn't seem right though. Unless they typed it differently. Let me look here. This goes into here. To add it, we'd have to have common denominator, yeah. I'm right so far. This should be 1 over 14x plus 1 over x. Which would be 1 divided by x over 14x, or I flipped it already. 1 divided by 14x plus 1 over x, which would be 1 times x over 14x plus 1. That's not right. Unless they typed this wrong. Nope. I'm going to say I didn't type the review. Did anybody do this one already? Because I'm going to do this the other way. 7 times.
I was confused on that one.
Alright, I'm going to do it the other direction. I'm thinking g of f of x might be their answer, might be wrong. G of f of x would be g function plus 1 over x, which would be 7 over x plus 7 plus 1 all over x, which would be 7 plus x plus 7 over x plus 7 all over 1, or x. Yeah, I think they just marked their answer wrong. I think it's a no. Easy way to tell. Let's do it a different way. Not the way they wanted you to do it, but if I wanted to find the inverse of f of x, if you went old school on it, this would be x is equal to 1 over y plus 7. Solve for y. Cross multiply. Yx plus 7 is equal to 1. Would be 8. No. There. 1 minus 7x over x. Yeah. Yeah, answer key is wrong. The answer is no. Those are not inverses of each other. It's interesting they didn't tell me. Yeah. Answer key had it as yes. That's why I was a little confused when I was doing it. But yeah, that's not going to work. Trying to see where it was at. I think they had a typo on it. Alright, yeah. So, anyway, you want to take your g of x and your f of x has to end up being just x, and f of x into g of x, and that also has to be x when you simplify it. And that's your rule. So, and those definitely do not work that way. Okay? So, yeah. And you don't want to do the other way either, so. Alright, so, sorry about the typo. Have another teacher do it for me. Alright, so, if the following defines a one-to-one function, find its inverse. Okay? So, is this a one-to-one function? Okay? The way you tell, horizontal line test would mean that you can't have the same y for different x's. So, this is not a function, a one-to-one function, because of those two negative 5s there. Okay? If they would have had 7s here, then you could rewrite their inverse. And don't forget, if you need to find its inverse, you just switch your x and your y's together. Okay? So number 4. If f of x is a 1-to-1, 1-to-1, find an equation for its inverse. Alright, so in this case, if I want to find its inverse, remember you switch your x and y, and you're going to solve that again for y, which means you're going to square both sides. Okay, subtract the 9 and you get x squared minus 9 is equal to y. Okay, now here's the thing. Okay, in this function they give you this relation. Okay, because this function would be, looks like that. But isn't this a quadratic? Okay, so this quadratic would look like this. But I can't use the whole thing. Okay, and so you're going to only use half of that. Okay, and where is it going to get at? This thing would be like this, and the only part you want is this piece here, which means I need the x is greater than equals 0 piece with it. Now they were nice of you, they made it nice and simple to pick the right one. Okay? Because it's the only one that has x squared minus 9. But the reason it has this is so that you only take half of the parabola. You don't want both. Okay? Alright, number 5. Okay? Find the domain and range of the inverse of this. Okay? Now, one of the things, so this is a quadratic. It's very similar to the one we just looked at. It'll look like this. Okay? But they only want the x values. So the only part they want is this part. Okay? So since they only want that part, that means this is the range, or this is your domain right here. And one thing you want to remember is your domain and your range flip. Okay, on inverses. So if this is my domain, my new range has to be the same. Okay, so the inverse range is all real numbers. Well, it has to be y is greater than 0. So that cancels out this one. Okay, that one's okay. These are from -7, -7. Okay, so these aren't the right ranges. It needs to be a range from 0 greater than to infinity, which means it has to be this one. Okay, and if you look at the original, this would be at -7. So its range from the original would be -7 into infinity. So that means the inverse to this would be the domain would be -7 to infinity, which also matches that up right there. Because your domain and range always switches. Right? And then the last one on this page says to find f of -3. We should know how to find f of -3. We plug it in. Okay? So this would be 5 to the -3 plus 2 to the -3. Watch your negatives. So 5 to the -3 is 1 over 5 cubed. 2 to the -3 would be 5, or it would be 2 cubed. And so this would be 8. So this is going to be 1 over 125 plus 8 over 1, which means you would need a common denominator to add that of 125, which should already tell you what your answer is, probably, unless it reduces. And then 125 times 8 would be 62. I lost myself. Is it 1,000? Yep. So 1,000 plus 1 is 1,001, which gives you that one. Okay? So, that's page 1. If you have a question, unmute yourself and ask a question from this first page. Everybody's good?
Yes.
Alright. So, a couple of these pages go pretty quick. Let's go to page 2. It says, write the equation and state the transformation given to that graph. Okay? So, if you remember, this is going, if it goes up like this, it's exponential. Now, we're nice of you, give you all the exponential versions, so this has to be in base 2. Okay? base 2, remember, it'll always go through here, and base 2 would have been something like this. Okay, so how did it move? Well, one of the things we should know is that the horizontal asymptote has moved down 1. So that means I'm going to have a shift down 1 no matter what. So there's your down 1 move, there's your down 1 move. So that means these two guys are done. Okay? And so, did this move left or right? Well, if you look at it, it's going to, the 0, 1 is always a key point. 0, 1. So it's either going to go right 2 or left 2. And so we already know it went down 1, and then it goes to left 2 right here. Because if I go down 1 and right 2, I'd go over here. The graph would be all over here. Which means this has to be my answer from my equation, which left 2, down 1 would be my transformations. Okay? So, number 8. 8 and 9 on this page, the key, try to get the same base. So here, you know this is base 2. So to get this into base 2, I'm going to change this 4 to 2 squared, which means this then would be 2 to the negative 2. So if I have 2 to the negative 2 is equal to 2 to the 7 minus 3x, if your bases are the same, you can set your exponents equal to each other. And then solve for the exponent. Okay? Which would be, subtract the 7, divide by negative 3, which would be 3. So C has to be 3. Same thing with number 9, same basis. And bases have to be exponents. So the only way to get 8 and a 4 to be the same, and really the way they did this, this 2 over 4 would be the same as 1 over 2, which tells you base 2 would be where I want to go. 8 is 2 cubed. So if I have, let's go down here, 2 cubed to the x plus 1, that would be the same as 2, and then I distribute the 3, so it'll be 3x plus 3. There's a delay on my camera. Equal to, this is going to be 2 to the negative 1 to the x minus 1. So that's going to be 2 to the negative x plus 1. Now I have same basis. Set your exponents equal to each other. Okay, bring this over. That's going to be 4x is equal to negative 2. So x is negative 1/2. And these answers you don't technically need to check. You could check them to see if they plug in right, but they should always work because in exponential they can be anything, and your base has to be a number. You wouldn't have a base of 0. Okay? Alright, questions on page 2. If you got one, unmute yourself. Okay? So let's continue. And some of these get you a lot of practice because there are some of these, and we want you to get these easy ones hopefully on the test. So, 10, 11, 12, still working on trying to get that same base. So, base for 16 and 32 is going to be base 2. Okay? So 16 is 2 to the 4th. X minus 2 is equal to 2 to the 5th is 32, x 4x. Okay? So, if you're getting the hang of this, you know the same basis, and so all I have to do is set my exponents equal to each other. So that would be 4x minus 8 is equal to 20x. And just solve. So this is negative 8 is equal to what, 16x. So x is going to be negative 8 over 16, or negative 1/2. Negative 1/2. Okay. Now 11, again, same base. Notice this one has base e, this one has base e. So it's very similar. We just put this in here so you don't freak out on base e. E to the x minus 1 is equal to e to the negative 5, x plus 4. Where do I get the negative 5 from? I bring it up top. The 5 goes to the top, it becomes a negative 5. That's the rule you have to know. So that means x minus 1 is going to equal negative 5x plus 20. Minus 20. Alright, so I'm going to bring the x, the 1 over, and the 5x goes the other side. So 6x is equal to negative 19. Divide by 6. I get negative 19 over 6. Okay? And then 12 is one more of the same basis. If you look at your numbers, there's a 7 and a 49. Well, I know 49 can be written as 7 squared. Square root of 7, if you remember back last semester, this would be 7 to the 1/2. So if I have 7 to the 1/2 to the x plus 4 is equal to 7 squared to the x, this is going to end up being 1/2 x plus 2 is equal to 2x when I distribute the 1/2. Okay, now I'm going to multiply everything by 2. X plus 4 is equal to 4x. Subtract the x, 3x, and I'm going to get 4 divided by 3, which is 4/3, which is D. You just got to watch out your signs. Okay? Alright, so 13, 14, and 15. The rest of this page is just writing them in different forms. Okay? So remember, log form, log base b of y is equal to x, is the same as saying the base b of x is equal to y. Okay? So I can do this in both directions. So this is exponential. They want it in log. So what's my base? My base is 4. So my base here has to be 4. So this one goes away. Take that one out. Take this one out. And then log base b of what? And this is going to be my exponent out here. So my exponent in my regular problem is 2. So that means my exponent's got to come out here, which means C has to be my answer. Okay? Then we can go the other direction, and all this is pretty easy. Base, exponent is equal to this. Okay? And then this one, my base, we have to do a little work, to the exponent is equal to 256. So what you have to do is you got to do a little work to figure out which one of these are we talking about. So this is 2 to the 1/2 to the 16th is 256, which when you do multiply these two together, I'll get 8, which means it's got to be this one here. Okay? So there's that page. Any questions? Alright, so that's just going, there's a couple on the test. Hopefully those are going to be easy for you on the test, as long as you follow your rule. Okay, 16 and 17, we're just solving logarithms. Okay, solving for x. Oh, I had to see how they did this here. Oh, I see how they did this. It's crazy. That shouldn't be there. Alright, so we're going to solve this for x. The nice thing about this is any base to the log of a base of some number is always going to equal that number. So if they equal bases kind of cancel each other out, so base 6 and this base 6 gives me my answer of 13. Okay? And then on this one, you want to change it to exponent form. So 3 to the x is equal to 81. So what exponent of 3 will give you 81? It'll be this. And then you can do it this way if you want it. I just always those two are equal to each other. Alright, so 18, writing equation of the given graph. Okay, so these are in base 2 of a logarithm. A logarithm always looks like this. Okay, and the first thing you can notice is your vertical asymptote. Shift it from the y-intercept over 4. So that means everything here had to have gone left 4. So your left move is going to be inside, and a left 4 is going to be a plus 4. So those are going to be gone. And then all you have to do is now determine, did I move up or down? Okay? And in this case, because this is way up here, your one move here, that's going to be your 0, or 1, 1. Everything went over 4. So if I move if we move this point over 4, 1, 2, 3, 4, that would have been here. This point over 4, 1, 2, 3, 4. Okay, which means it would have gone down 1. Wouldn't have gone up 1. Up 1 would have been much higher. Okay. 19, and then the next couple after this, you are using your log rules. Okay, so remember your log rules. If it's multiplication, they break apart using addition. If it's division, they break apart using subtraction. And then if there's a power, you're going to deal with the power. Okay? So, these take a few steps. Well, actually, this one's not bad at all. Because right here you have a division. So if I break that division apart, it's going to be by subtraction. So it's going to be 4 root 4. Okay? Which is... trying to figure out how this one was done. Minus log base 4 of 5. Okay, so that's got the last one here. So this one's going to be gone. Trying to see which way they went with this. That could be that. Oh, I would have done this a totally different way than the answer key, but I see the answer there. Okay, so they separated this out. Log base 4 of 4 plus log base 4 of the square root of 4 minus this. Okay, and then this is to the 1/2, which means this would be 4 to the 1/2, and your power rule brings things out to the front. Okay, so you have to have the 1/2 in front of this, which is this one. Now that's a horrible answer because there's a lot of things in there. Those of you with pre-cal and stuff, there's a lot of things that could have simplified in here. Mainly this is 1. Okay, and then this, you could easily simplify that down to a 2 and just make log base 4 of 2. So, but this would equal to this. Okay, so that's probably one I need to have them rewrite. Alright, questions so far before we get to 20? redo this one. Alright, so let's look at 20. What I'm going to do real quick, I'm going to pause just for a second. I'm going to